everybody. Now today we're going to be looking at solving algebraic equations by elimination and then applying our solving methods to some story problems, which I know you love. So first of all, this is kind of just a little map out of the steps to take the solving. So when we have two linear equations, the first thing we want to do is get them all in standard form, okay? And so put everything in standard form. So all of our variables are on one side and all our constants are on the other side, and that makes it easy to solve by elimination. So here we want to add the 3y to the other side, and this is already in standard form. So this way we have the ability to line up the variables, so to speak. So put our x's over the top of each other, our y's over the top of each other, and our constants over the top of each other. So 2x plus 3y equals 16, 5x minus 4y equals negative 6. So I kind of put this in this way so you guys can kind of have a reference to look to for some notes if you wanted to take a picture of it or whatever. So determine which variable to eliminate. This is the trickiest part. Do I want to eliminate the y or the 5 and 2, or the x variable? And so in this case, they picked the x variable, and what's going to happen is I'm going to multiply all of this by a 5 to get it to be 10. So I want to think about what's my lowest number I can multiply to get them to be the same number. But we want them to be opposites so that when we add them together, they'll be 0. So I'm going to multiply this one by -2 because that's going to give me a -10. So notice that these two right here are opposites, and that's our goal, is we want the terms to become opposites, okay? And so now when we get that together, we're going to line them straight down, and we're going to just add these straight down. So 10x plus -10x is 0. 15y plus 8y is 23y. 80 plus 12 is 92. And then all I have to do here is divide by 23 on each side, and I get y equals 4. Well, now that I know what one variable is, we got to figure out what the other variable is. And so I substitute the result into either of the other equations. So I can do it to this equation or this equation. It doesn't matter which one. So in this case, they plugged it into 2x plus 3 and then times 4 equals 16. This will end up being 2x plus 12 equals 16. And then we subtract 12 from both sides, giving us 2x equals, and we subtract 12 would be 4, and then we divide by 2 to give us our x equals 2. So my solution is going to be 2, 4, right? That would be my solution to my system of my equations. And of course, you always want to probably check it back into, if you check it, you want to plug it into both equations, and it should make both equations true, not just one. Okay, that's the important part about systems of equations. It should be that point of intersection. Okay, so let's go ahead and try this. So this case, I'm going to look and see, these y's are the same number, same coefficient, and they're opposites. So that's kind of beautiful. It's kind of set up for us. So I'm going to eliminate the y because these are opposites already. So I'm just going to add these all together already. So 3x plus 1x is 4x. And then this one will just be 0 equals, and this will be 8. So that was kind of nicely set up for us. So we divide by 4. We have x equals 2. Okay, so now we got to find out what y is. And I'm going to probably pick this equation here. So I'm going to go x, which is going to be 2. I'll just use my blue still, I guess. So I'll put 2 and then plus 4y equals -2. And I'm just going to solve for that. So if I subtract 2, I end up with 4y equals -4. And then we'll just divide by 4. And that will give me y equals -1. And so my solution, remember, is always a coordinate, is 2, -1. And that's my solution to my system. So if I plug that coordinate into either one of these equations, it will make them both true, not just one. Okay? Let's take a look at one more. Now in this case, I don't have any two coefficients that are exactly the same. So I need to pick one that I want to have become the same. Okay? In this case, I think I'm going to pick the y. Okay, and so up here, I'm going to multiply this by they're already opposites, by the way. So I don't need to worry about making one negative or positive. So I'm going to multiply this one by 3, which will make it a 6, right? And then down here, I'm going to multiply this one by a 2, which will make that also a 6, okay? So that's going to make this equation, -5 times 3 is going to be -15x, and then plus 6y equals 27. I always try to multiply by the smallest number I can so that the numbers don't get too huge that I'm working with, okay? This one over here is going to become 4x And then 2 times -3 is a -6y. So you can see these to become opposites right here. Equals, and -19 times 2 gives me a -38. Okay. And so these right here, if you notice, these are opposites. And that's what we want, because when we add them together, they will become 0. Okay, 0. So this becomes -11x equals, what is that? -11. So that's nice. So we have divide by -11. So x is equal to +1. Okay, so that's what our x value is. What is our y value? So now we're going to come over here and plug this in for, let's go to the bottom equation. So 2 times 1 right here, minus 3y equals -19. Okay, so 2 minus 3y equals -19. I'm going to subtract 2. So we have -3y equals -21. Divide by -3. And I find that y equals a +7. So my solution is going to be 1, 7. That's my solution to my system of equations. Okay, so that is elimination. All right, there's more than a couple ways to solve this, right? I could have chose to eliminate the x, and I'd probably multiply the top by 2 and the bottom by 5, and I get some different numbers. So there's no one perfect way to solve these systems. Okay, well, now let's put this into some practice here. Okay, so a total of 420 tickets were sold for the school band concert. The number of student tickets were sold was twice as many as the number of adult tickets. How many adult tickets were sold? So the first thing I'm going to do is I'm going to say, well, I'm going to let S equal the number of student tickets. Okay, student tickets. And I'm going to let A equal the number of adult tickets. Okay. And then I can start writing some equations. Okay. So total tickets sold were 420. So that's, first of all, I can go A plus S equals 420. So the number of adult tickets plus my student tickets is 420. Okay. So that's right here, total of 420. The next thing I'm going to be able to pick out here is the number of student tickets sold was twice as many as the number of adult tickets. So how do I write that as a relationship? Okay. So the number of student tickets equals, right, is twice as many as the number of adult tickets. So 2 times as many as the adult tickets. Okay. So here I have a system of equations. Right here I have 2 equations, 2 variables, 2 unknown variables. Okay, 2 equations, 2 unknown variables. Well, I could probably use substitution in this because I already have S equals 2A, right? So I could plug in this 2A up here. So I could go 2A. Sorry, I'm plugging that. I do that every time. I want to plug this not into A, I want to plug it into S. Silly. Okay, so then I'm going to go A plus, and that's where I'm going to plug in my 2A is for S. So times 2A equals 420. Okay, so an A plus 2A equals 3A equals 420. And then that gives us A equals, and what's 420 divided by 3, I believe, is 140. 140 tickets. So my number of adult tickets was 140, which means my student tickets is 2 times 140, right? Which gives me 280. Now, I don't think they asked for that. They just want to know how many adult tickets are sold. So this is really my answer right here is 140 adult tickets were sold. Okay? So that's how you set those up. Okay, define some variables, set up some relationships. So let's try this one here. Okay, we have the Jazz scored a total of 80 points to beat the Blazers. The Jazz made a total of 37 2-point and 3-point baskets. So first of all, I'm going to go ahead and define X is going to be my 2-pointers. I guess my number of 2-pointers. Okay, and then my Y is going to be my number of 3-pointers. Oh, come on. 3-pointers. There we go. 3-pointers. Okay? 2-pointers. So we know we have a total of 80 points. So we know that if we take 2 points for every 2-point shot made, plus 3 points for every 3-point shot made, it's going to give us a total of 80 points. Okay. So we have 2 points times every point shot, every 2-point shot made, plus 3 points for every 3-point shot made. Total of 80 points. Okay. How many 2-point shots did the Jazz make? Oh, let's see. The Jazz made a total of 37 2-point and 3-point baskets. So that means that the 2-point plus the 3-point baskets equals 37. Okay, so the total number of actual baskets made is 37. So now we have a system of equations here. We can use elimination here is what I would do, okay? Because we already have it set up to where they're stacked on top of each other. I could easily multiply one equation here. I'm going to just multiply this by -2 to get these to be opposite. So I could come over here and rewrite my 2x plus 3y equals 80. This would be my -2x minus my 2y equals, and then 37 times 2, what's that, 74. So -74. And we just add top and bottom here. So that's 0. Y equals 6. So there we go. So the number of 3-point shots made was 6. So then we're going to come back up here. Let's plug this into x plus y. So we have x plus, and then we're going to plug in 6 here, equals 37, right? So if I subtract 6 from 37, we have x equals 31 shots, 31 2-pointers that were shot. So we made 31 2-pointers and 6 3-pointers to beat the Blazers in that game, which we all know happens. Okay? All right. You guys have your assignment in Google Classroom. It's just a shorty one again. So I will see you all in Classroom, and I'll talk to you soon. Bye-bye.